So again, good morning, good morning. Like I said, get out your notes packets. We're going to go over the worksheets for sure. I can go over some textbook problems if you have issues. I don't have my textbook or anything with me, but I can pull up the PDF copy just like you can. So we could go through any textbook questions. So if you know there is a question from the textbook, a question from the homework, or anything that you specifically want to see or go over, you can send me a chat on Zoom while we give your classmates 1 or 2 more minutes to join us. I'm going to cut them off at 38 for their join time. So again, if there's a specific homework problem from the textbook you want to see, send me that in the chat now. Otherwise, we're going to go through the worksheets and then the 4.3 review and justifications in your packets. All right, so on page 215, we have an example of a piecewise function. So in order for a piecewise function, we have to first check continuity in order to determine differentiability, in order to determine if we have concavity and all our special points. So the original function was 2x and then 2 minus x squared for x less than 1 and x greater than or equal to 1. So at 1, 2 times 1 is 2. And then at 1 here, we have 2 minus 1 squared, which is 1. So what we know is that this function is not continuous at x equals 1. Therefore, it's not differentiable at x equals 1. Therefore, x equals 1 is where a derivative does not exist. So it is a point of concern, just in the sense that we know a derivative can't exist there. So it's going to create a hole on f prime. So we find our derivative of each. So the derivative of 2x is 2. The interval stays the same. The derivative of 2 is 0. The derivative of negative x squared is negative 2x. And we have x greater than or equal to 1 as our interval. But we now know on this interval, it can no longer be equal to 1. So that part of that domain is actually going to go away. So it's just now going to be x greater than 1 and x less than 1. So we're going to get rid of the equal to. In order to find concavity, we have to actually find our second derivative. So y double prime, the derivative of 2 is 0. And the derivative of negative 2x is negative 2. And the intervals stay the same. So it's x less than 1 and x greater than 1. Okay? Go tell Daddy. Corey, go tell Daddy. Go tell Daddy Connor's crying. He's in the basement. So where is it concave up? Concave up and concave down. So it's concave up where the graph would be positive. Well, if you look at that second derivative, this is never positive. Therefore, it's never concave up. And it's concave down where that graph is negative. So it's negative for all x values greater than 1. And again, not equal to 1 because it's not differentiable at 1. So hence the 1 to infinity. And it muted me out. All right, so that's example number 11. Now, example number 19 asks you for your point of inflections. So in order to have a point of inflection, we have to go through the concavity test and look for a sign change on that second derivative. So this might be maybe somewhat like messy in terms of derivatives, so we're just going to take it kind of slow and work through our derivatives of each. I did kind of like try to look at the question real quick and be like, okay, can I factor this in any way? But the 2 on the x squared kind of really makes it that you can't even do factor by grouping, because that's what I first investigated, especially seeing that x minus 1 at the end, but it doesn't allow for factor by grouping. So we're just going to go through it and do Hody Hi minus Heidi Ho twice. I personally will probably clean this up and hope that something somewhere in there cancels before trying to just Hody Hi this again. Okay, so we notice that I have 3x cubed and negative x cubed. So that will reduce to 2x cubed. And then I have negative 4x squared and positive 2x squared and a negative 3x squared. So negative 4 and negative 3 became negative 7. Negative 7 plus 2 became negative 5x squared. And then I have 1x, 5x, and then another negative x. So that takes me back to 4x. And then negative 1 and positive 1 cancel. And again, I don't have to do anything with my first derivative because I'm not being asked about anything from the first derivative. So I'm just going to move down and go to my second derivative. So ho d high minus high d ho all over ho ho. And I notice that I have x minus 1 here and x minus 1 there and 4 down in my denominator, so that'll become 3. So I'm going to cancel 1 from this term, that term, and the bottom. So that leaves me with x minus 1, 6x squared minus 10x plus 4, minus, and I'm going to distribute the 2 and the negative at the same time in this last term, 4x cubed. Negative times a negative is a positive. 2 times 5 is 10x squared. and 2 times 4 is 8, and distribute my negative is negative 8x. And again, that's all over x minus 1 cubed. So now it asks me to find my points of inflection. So a point of inflection can occur where the numerator or denominator equals 0. So at this point, you could distribute and set all of your numerators equal to 0, and also set your denominator equal to 0. So I might just clean up that numerator a little bit more. So we have 6x cubed minus 10x squared plus 4x minus 6x squared plus 10x minus 4 and again we're setting all of that equal to 0. So 6x cubed and 4x cubed give me 2x cubed. Negative 10x squared, negative 6x squared, and a positive 10x squared. Well, the negative and the positive 10 cancel. So I'm left with negative 6x squared. And then I have a positive 4x and a negative 8x and a positive 10x. So 10 and 4 is 14. 14 minus 8 is 6. And then that leaves me with a negative 4. So you'd have to find values at which that would equal 0. So I always kind of quickly check like 1. So I go in my head, okay, 2 minus 6 plus 6. So they cancel. 2 minus 4. Nope, doesn't work. 0 doesn't work. And then I always kind of go back and check like my negatives. So that would give me negative 1. So that would give me negative 2. Negative 2 minus 6 is negative 8. And then again, negative 6, negative 4. So that doesn't work. So we just kind of work through and go from there. Remember your rule, it is P divides Q. So you have 1, 2, 4 over 1 and 2. So my only potential factors are 1 over 1, 1/2, 2, and 4. We also set our bottom equal to 0. We know that if it's cubed, you cube root both sides, which is 0. And then you get x equals 1. So x equals 1 is where f double prime of x does not exist. So we know for sure it's going to go on my number line. And then going back over to this side and still just kind of like working through, if I put in 4, 4 cubed is 64. So I don't want to spend a lot of time, but that's how you would do it. And I know that because I know the answer, x equals 1 is my only POI. None of these rational roots, when you plug them in, will give you a 0. If it was a homework problem with a calculator, you could easily plug this into your graphing calculator and see if it has any zeros where it crosses that line. I don't believe a graphing calculator. Actually, I do have a graphing calculator right here, so I could even show you that. So you can actually see that at 2, which is what I was actually getting into, plugging in here, we have a 0, so we can use x equals 2 on my number line as well. So all I did was in y equals type in my function, and again I told you we knew the p divided by q, so I knew my potential roots were plus or minus any of these values, and we can see from the graph that we actually have one at 2. So x equals 2 comes from over here. If you recall synthetic division, and I'll show you real quickly how to do that, that's another way to easily find the zeros. So what you do is you take your p divide q, you put 2 in the box, you write down the coefficients of the terms, and this is called our remainder theorem. So what we're doing is we take all the coefficients of the terms, we take the possible roots, and our goal is to get a remainder of 0. And if you do synthetic division and you get a remainder of 0, then what that means is that x equals 2 is a 0 or root of that function. So synthetic division actually says any number you put in this box and you do synthetic division for tells you the value of that number. So if I wanted to know for my number line purposes, so like we know in our number line now, we have 1 and 2. If I wanted to know for the purpose of this problem what the signs were around this and actually know what their values were, I could say, for example, plug in the number 1/2 right there. I could plug in all those same synthetic values. So again, you take the coefficients of the term and you perform synthetic division. So you bring down the first term, 2 times 1/2 is 1. So then you get -5, and then you get -5/2. So now we're talking about, in this case, because I picked a fraction, maybe not something quite so nice, but 5/2 in this case is 2.5, so 6 minus 2.5 isn't terrible. And then you get 3.5 times 1/2, which is 1.75. And -4 minus 1.75 is a negative. So again, you don't really care what the value is, you just care about the sign. So it's -2.25, and I know if I plug in 1/2, because remember you still have to take into account your denominator, 1/2 minus 1 is negative, and a negative number cubed is negative, so negative divided by a negative means that I have a positive between 1 and 2. And then you would repeat that process. So you'd plug in 0. So you'd get 0, 0, 0, -4. So my numerator is negative. And then 0 minus 3 is -1. So my denominator is negative. So negative divided by a negative. Hold on. Where did I go? 0. Did I do my 1/2 wrong, maybe? Because they should be opposing signs. Nope. Maybe your book is off. Plug in 3, because that will be positive. 3 minus 1 is 2. 2 cubed is 8. And then if you plugged in 3, so again, using synthetic, assuming you didn't have a calculator, so I have no POIs. Your textbook had a POI at 1, 1. But 1, 1 isn't even in the domain. I'm pretty sure your textbook answer is off, because 1, 1 isn't even in my domain. So, good. I'm going to check that in the official scoring textbook guide that I have. So in this case, there are no POIs because there are no concavity changes. And again, you can confirm everything graphically on your calculator. Like I said, synthetic is really nice. Hopefully you guys remember that technique from Algebra 2 and from trig. Synthetics super helps you like get those answers and those signs as well as your roots. So it's just an easier technique to help you work through each of those factors. Okay, so the other thing I wanted to look at is your worksheets. Okay, so as I kind of like mentioned, we went through the second part of this paper already as our warm-up the other day, but you are looking at your graph and trying to find out where is it increasing and where is it decreasing if this graph represents the function y equals f of x. So it's increasing a to c, decreasing c to e, and increasing e and on. Now, if it's a closed interval, then it would be e to g, which it is a closed interval. So again, just kind of looking at that original graph. The second problem, though, is not the original graph. The second problem is the derivative. So the derivative changes now. So now the original is increasing where the derivative is positive. So now my levels of increase are from B to D and F to H. So now if you're given the derivative, your increasing is where the derivative is positive. And then your decreasing is where your derivative is negative. And that's what your reasoning needs to say. Something along the lines of the function g of x, and you want to say what function it is. So you can't just say the function, because sometimes you're going to have problems that'll have like an f, a g, and an h. So saying the function isn't sufficient. You have to give the function's name. So in this case, the function is g of x. So we say that the function is the function g of x is, and what is it doing? It is increasing on what interval? B to D and F to H. And then similarly for decreasing, you'd say the function g of x is decreasing on the interval A to B because g prime is negative from A to B. Okay, here's the concavity handout. So I think concavity trips us up a little more than increasing and decreasing. So it says for this first part, question 1, suppose that f is differentiable. What intervals are the second derivative equal to 0? So the roots would come from when x minus 1 and x minus 2 equals 0. So our roots are at x equals 1 and x equals 2. We call these repeated roots because they are essentially roots that are occurring more than once. An even repeated root will not have a sign change, where an odd repeated root can. So that's the difference between those two examples. And then for your second part, suppose that g is differentiable. A graph of the derivative is given down below. So here we have that g double prime is equal to 0, and we have the values at which it's equal to 0. So I'm going to give you a second to read what's in red and check your assignment. Okay. So looking through and working through these, again, the biggest point of concern is talking about where the derivative is equal to 0, where the second derivative is equal to 0, and then checking those points on the number line. So I know there's a lot in red on that screen, but the big idea is, okay, where are f double prime equal to 0? So those answers are at -1 and 1/2. And then do we have sign changes around -1 and 1/2? So that's where you're creating your sign chart. So to the left of -1 and to the right of -1 and then to the right of 1/2. And again, if you need to see sign charts for those, I have no problem working through them. A lot of times the answers that the AP College Board classroom assignments are giving are more wordy because that's what they would expect on their AP exam. As I've told you as we work through these, a sign chart is not sufficient. You have to be able to put that sign chart into words, and that's basically what's happening right here. So because the second derivative is positive from -infinity to -1, and it's negative from 1/2 to infinity, then we have these sign changes and therefore points of inflection. So example number 2, it says suppose that g of x is equal to this and its derivative is equal to that. Very similar to question number 19 that we just previously looked at. And they give you the second derivative, which that's what I've seen more in your tests. So the AP exam typically won't give you something like 19 where you have to work through all three derivatives. It's going to give you the derivatives and then ask you to find questions or interpret it. So I've seen a question like this where they actually don't even give you the original because that's too much information. They'll give you the derivative and the second derivative, and then they'll ask you these types of questions. So for that scenario there, what you would do is take that derivative and have to set it equal to 0. So you would take 18x and x plus 1 and set that equal to 0. And you take x squared plus x plus 1 cubed and set that equal to 0. Let's go back and almost look at that. So to do that problem, you would set your tops and bottoms equal to 0. So that would give you x equals 0, x equals -1, and okay. So I believe that's pretty much kind of like what they had. So we also would then just take out and look at our other values. So let's see, for this, if I plugged in a -1 or a +1, those are my other two potential roots. So again, doing P divides Q, it could be a +1 or a -1. So just working through synthetic, you'd have 1, 1, 1, and 1, 1, 1. So let's see if any of those work. 1 times 1 is 1. So 2. 2 times 1 is 2. So we get 3. So that's not a root. And nor is this. So only two inflection points are at 0 and -1. So we look for sign changes. So something smaller would be -2. So that would give you a negative. A -2 plus 1 would give you a negative. Negative times a negative is a positive. And then that would give me a positive on top. And then on the bottom, -2 squared would be 4. 4 plus 1 would be 5. 5 minus 2 would be 3. 3 cubed is positive. So that is a positive. Plugging in something like -1/2, well, that's going to change things a little bit now because that gives you a negative on the outside, but a positive here. So we're going to get a negative up top. And then -1/2 plus 1 gives you a positive, and anything squared is positive, so you get a negative over a positive, which is a negative. And then plugging in 1, that's a positive, 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 positive. So we get a positive. So we can see that I have a concave up, concave down, concave up, therefore making -1 and 0 both points of inflection. So that's how they got this. There's definitely a typo in College Board. That should be a -1. They have it correct down here. I'm not sure where they lost it on their answers. Okay, scenario 3. This is definitely something I have seen on AP exam after AP exam. They love to give you a graph of a derivative. By giving you a graph of a derivative, they are giving you this idea of, can you interpret what that graph means? And can you take that graph forward as well as backwards? So something like number 3 is almost guaranteed to be on your AP exam. So it says in part A, what are the x coordinates of the inflection points of h of x? So that's the original, but we're given the graph of the derivative. So the inflection points of the original, given the derivative, will come from the extrema of the derivative. So that's your C, E, and F. The POIs of the original come from the extrema of the derivative, so C, E, and F. The justifying. So this is the part that I think we're struggling the most with. The justification in terms of words needs to be something like, for example, for point of inflection C. X equals C is a point of inflection because as the graph of h prime of x is increasing at x equals C, it changes to decreasing. Therefore, on the original graph, we would have a point of inflection. You could also say because h prime of x is increasing from A to C and decreasing from C to E, we would have a sign change on the derivative to the left and to the right of C. So they're looking for, can you put into words what is happening on that graph that would justify these reasons? So like you can see, their example answer is an inflection point occurs when the second derivative changes sign. So that was my second justification. This would change sign because it goes from increasing to decreasing. Or decreasing from C to E to increasing E to F. Therefore, at x equals E, we would have a sign change. They didn't ask you to do this by any means. This is a potential example of the original function. Again, potential. Okay. And then the last thing I had you look at was justifying. So these are checking if you can apply that second derivative test that we talked about. And basically what we're doing here is giving you values, and then can you interpret that? So if the derivative is positive, then the original is increasing. So since the derivative is positive everywhere, then the original graph is increasing. If the second derivative is 0, then those are potential points of inflection. So that's why it's giving you kind of these key pieces of information. It's also telling us it's differentiable, which means it's continuous, which means there are derivatives at both the first and second derivative without holes. So if f prime of 3 is negative, then it's decreasing at 3 on the original. So it says, does a of x equal f of x squared have a critical point at x equals 4? So if a function is squared, how does that change my values? Well, what that means is the derivative of a of x now becomes a prime of x equals 2 times f of x. So in order to find if there's a critical point, I have to investigate a prime of x, knowing that a prime of x is equal to 2 times f of x times f prime of x. So I want to know what a prime of x when x is 4. So it's like 2 times f of 4 times f prime of 4, which is 2 times negative 3 times f prime of 4, which is 2. So 2 times 2 is 4. 4 times negative 3 is negative 12. So negative 12 is less than 0, obviously, so it is negative. Does your table match what table? I need to look at your answer papes, because they're acting like those are different. Yeah, that's why I was just trying to pull up your worksheet. So this is like the answer page, obviously. Does yours go f prime, f double prime, f of x, or is yours in the actual order, like f of x, f prime, f double prime? So like College Board made a huge typo. Because if you go f of x, f prime x, f double prime x, then all of their numbers match this as well as their answer key. Good job, College Board. Yeah, that's what I just got, because I got a prime of 4 is negative 12. Like you can, which it definitely is, which is the second typo I found on their paper, which Nimsy was like, oh, whoops, I should probably pause this. Out ahead of time. So if you correct the table and you go f, f prime, f double prime, and you don't follow their typo, then these are the correct answers. So if you read the table incorrectly, then these are the answers you should have gotten. If you want to go back and practice because you're not feeling great about it, I'm going to record the answers here so you could go back and look at that. And in the meantime, I'm going to correct my worksheet as well as see if there's a way to put a comment on College Board. So again, assuming the table was typed correctly, these are the answers you should have gotten. And I apologize. So what I want to do for today is we only have 6 questions I want to look at. I want to look at the review, and that would even be your homework assignment for tonight. I want to look at the 4.3 review, and I want to look at the writing justifications that Nimsy created, and I have used a million times in the past, so I know it's correct. So if you guys want, I can put you back into breakouts. We can stay together as a group and kind of stay on screen. I already worked out everything from the review, and I worked out everything from the writing justifications. I know that it's been a lot. We've just worked for 40 minutes on these past couple problems, working through, talking about everything, and finding typos like crazy. So